This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Okay. Oh, can you guys hear me? Hello, hello. Let me get this a bit louder. Oh, a bit too loud. Okay, good afternoon, guys, and welcome to our fourth lecture on programming and software development. Today we're going to be covering methods, which is, I think, an exciting lecture to have. It gives you so much more control. Before I begin, hopefully you all had a very positive experience with the assignment. I haven't been able to respond to any students' questions over the weekend. I was actually Aussieing up and I went camping with some guys, which was probably the scariest thing I ever did in Australia, just because it's, well, in my opinion, it's quite dangerous, but obviously to anyone who's familiar with Australia probably thinks I'm what they consider a sook. Anyway, so I will respond to your emails for whatever emails are there over the next few days. The Lab 1 sample solutions are now available on the LMS so that you can review the solutions to the work. I always ensure that you have about at least 2 weeks to rack your brains and to try and gain your own solution as a way of a sort of a learning curve. That's how I feel it's important for you to do, is for you to actually work on the solution yourselves. Don't be tempted to wait until the solutions come out so that you can see how it should be. Honestly, you learn so much more through trial and error. So the more you try and the more you fail, the more you learn. Okay, so I would advocate practice, practice, practice. It's so important, and I can't express that enough. You really do need to practice. It's not something you can just listen to, absorb, and then pass. Practice is what's going to make you do really well in this course. I've had some feedback, which I really enjoy. I really like having feedback, and the feedback was that I was going a little bit quick last week. So I will try and slow down and give more examples. Some of the feedback to actually give more physical examples, which I will do today. I'm happy to have feedback from you at any time, because at the end of the day, sincerely want to be able to deliver the material to you in a way that you learn. I always believe that it's my job to try and change the way I teach to make sure that you can learn the best that you can. So by all means, always come to me with feedback, and I will try my best to incorporate that into the lectures if possible. If not, of course, I'll just explain why I can't. And next week, this is a very important announcement, next week I won't be here, but the lectures will continue. So you have, you're blessed actually to have Professor Peter Shakte, who has taught programming for many, many, many years. He's incredibly good, a real gentleman. So he will be teaching in my, it is week 5 next week, isn't it? Yeah, so it's next week, just in case I was giving you the wrong. So week 5, Professor Peter Shakte will be teaching in my place. So the lectures will continue as normal, but you will be privileged to have his teaching for that duration. He's very good, so you won't be missing out. In fact, you might beg to have him continue, which I hope you don't. But anyway, but he's very, very good, so it'll be an exciting lecture. So today we're going to cover, sorry, I just burnt your eyeballs out. We're going to cover methods. Last week we did conditional control, so we learnt about loops, we learnt about various ways of controlling the flow of data through your code. Today is a very important one because methods play a huge part in the way that you develop code in any language, particularly in Java. So for those of you who have programmed, a method is exactly like, if you've done C or Python, it's a function, very much similar to a function. It has differences. It has a little bit more interesting control mechanism that you can utilize, which I feel are very, very exciting. But for those of you who haven't done much programming, a method is a way of encapsulating, bringing together a certain type of code or any code that you want to reuse again and again by calling the method name. So it's a way of maybe keeping your code in a vault or in a special little container, and then you call the name of that container to execute that level of code, right? Now, Java itself has many, many, many methods. If you recall, if you put in Java API into your browser, and you look at what Java has under this is the Java doc, you'll be producing this kind of framework. This kind of what you're looking at now, all this code, you will produce that yourself as you develop through this course, and it's built into the Java software development kits. You create a Java doc, and I'll show you as we go along how to do that. But these are all methods and classes or objects that are available. So if you were to look at any, I don't know, no, maybe an object. If you look at any trying to go right down to the metal. You can see there's many, many. If you look at any sort of object, not just the word object, but any object, I'll go into objects again later, but they all have methods. So all the methods that they have, we'll be covering, for example, this one here, the toString method, originates from an object class. And I'll explain how we make our own methods and how we use our methods and when we should make methods, right? So that's kind of what we're going to be covering today. So again, they're similar to functions, subroutines or procedures. There are two kinds of methods. You have a class method and an instance method. If you remember from week 1, I think I mentioned that I would go into the static, public static void main. I'm going to go into one aspect of that today, and that is the concept of static. So static, also known as class, a class method. We'll be showing you how, or I'll be showing you how to create your own methods, your own class methods. I'll cover non-static methods next week. But hopefully you'll have a really good understanding of how to invoke a method, how to call it, how to create it by the end of this lecture. So a point to mention is that instant methods. So we're going to be covering today these ones, this class methods. Instant methods are more common, and often we refer to instances of any class as an object. And again, I'll cover that when we're covering objects in the next lecture. Or not the next, you'll see. Any questions at this point? I wanted to ask, actually, was there any questions from last week in terms of the control statements? Did anyone have any questions at all? Just from some of the feedback I had, I felt maybe I had covered things a bit quickly, but if there's no questions, I'll just carry on. So calling a class method, it's created in the body of your code. So what I'm going to do, I'm going to start making a little project of type car or a toy car, and we'll basically generate methods, we'll generate control statements, we'll generate classes and objects as we build up that sort of complexity of the program. It'll be very basic in general, but if I was to show you the kind of end result now, you would think, okay, you'd probably walk out of the class just because it probably is complex when you're first beginning. So a class is created, as you remember, this word class here is defining the name of your class. So if you have a static class, you can call the methods within that class from any other method, assuming that they are public. We'll be covering the protection of classes and methods later. But for now, the word class here is not the right use of that word. The word class here is simply stating the name of your class. So the word class is the word class is the name of your class. Then you have a dot, and then the name of your method. So you'll create a class called Google Binder, and then inside Google Binder you'll have a method called shoelace, and you would call Google Binder dot shoelace, and then you'll do the brackets, and you'll give your expressions, and I'll go through these with you now. Obviously, if you're producing the method inside the class that you're in, you can just call the method without calling the class name, or you can do both. One way I think about static methods is they are tools, almost like a utility knife. You design a tool and you put it down in your code, and then you can call that tool and provide information to that tool at any time without having to create a version of it, without having to instantiate it. You don't have to make a version of it in memory. You simply call it, and it executes that static method on command, if you will. So let me give you an example. So if we go into NetBeans, I will try and go quite slowly through this. So I'm going to go and create. So what I've done is, oh my God, hang on, that was a mistake. I'm trying to turn the screen off. Okay, whatever. Okay, it is bothering me. Sorry, the screen keeps coming on. It was worth this. That's high tech, right? Just put my jacket over the screen. Okay, so I've created a package called Lecture 4 to coincide with this lecture. And I did that simply by right-clicking on the project, going to New, and clicking on Package, and then I gave it the name Lecture 4. So I've done that pre this lecture. Now I right-click on Lecture 4, and I click on New Class. Okay, so I'm just going to make a standard class. I'm going to provide, we'll call this class example 1 for now. And I'm going to just create a standard class. It has no main in it at the moment, and we won't worry about that for a second. Is that clear enough there? Can everyone see that clearly? Yeah, excellent. So I wanted to highlight just before I began this, some of you had issues where you couldn't submit your work into the system. It was giving you errors even though the code was correct. The reason for that on many occasions was this. So this package simply means the code that I'm running is inside a folder called Lecture 4. So if that code wasn't inside a folder called Lecture 4 when you submitted it to the Java compiler or to the server, it would reject it because it can't find the folder. So the advice is just to remove that package. If you've worked in an IDE, the chances are it'll produce a package, not always. And if that's the case, remove the package before submitting, so that doesn't, and then just submit the file as you normally would, right? And that's really important because the way Java works, it's looking for that package, that sort of folder with the information in for it to run. And if you don't provide it, you can't use it. Another thing I'll go into, maybe if I've got time today, I'll go into, you may have seen the template, this template here. Normally you get a lot of junk and it will say things like to do your code here. Now I've had in the past students who have actually provided this comment, your code here, as part of their submission. That's not necessary, so take away all this. All this can go away. Obviously, I've produced this commenting as part of a template ready for this class. I will show you at a later date, actually, how to do that. It's quite simple. But it makes your creation of classes very easy. So anyway, so I've created a class called example1. I'm now going to create a main method, so public static void main tab gives me the main method. I'll do it this way just so it's quicker. This is a static method, and this is the keyword here, is what we're actually focusing on today, or right now, sorry, this keyword static. This means that I can call that method from other methods as long as it's public. So I can call this method, well, I don't need to with the main, but I'll show you how to make one in a minute, from at any time without having to instantiate. Instantiation is what you do when you create an object, which we will be doing a lot of. So I'm going to create a method, and in this case I'm just going to call it, well, I'll do public static. Again, this is making it available anywhere. And in this case, I will say my car. So I'm calling a method called my car. And it also needs, it needs a return type. In this case, I don't want to give a return type. I don't want it to return anything. I just want it to do something. And in that case, I put in the word void. So void simply says, look, I don't want you to give me anything back. I simply want to use you for the purpose of what I want to do. So what I've done now is I've simply created a basic method called myCar, And the brackets are not optional, so you need the brackets. You don't put a semicolon. It's very common when you're starting out, honestly, it's very, very common, a rookie mistake, to put a semicolon here. By doing so, you simply terminate the method body, and it would not allow the method to function. So no semicolon here. And then anything I run in here, so if I just put a system.out, this is my car. Now I've got a method called myCar, and every time I call myCar, it will run the sequence of code inside my car. Now, if I run this code, which I will do now, Shift and F6 on thing, nothing happens. Can anyone suggest to me a reason why nothing is happening? I didn't understand any of that, but I'm guessing you said that I'm not calling it from main, right? Yep. My hearing is awful. Anyway, so to call a method from within the class that you're in, you simply call the name of the method, followed by a semicolon. Okay? So now this will run my car. Now, if the static wasn't there, like so, you can see that the IDE is giving an error. It's giving an error because I'm inside a static method. So you can only call static methods, you can't call non-static methods from a static context. So in other words, because I'm already inside a static method called main, that static method enforces the fact that I must then call also a static method. If I don't want to call an static method and I want it to be an instant method, then I have to make an instance of that, which I'm not going to do right now. So for the purpose of this, we'll try again. We'll have a static method. So now it's going to call a static method. And of course, when I run this, it says, this is my car, which is the output that we were expecting. Right, so far so good? Any questions at this point? No, excellent. Okay, I say excellent. It'd be excellent if you gave questions as well. Oh my gosh. So far, I've created a method, but I've not provided any expressions or expression calls. Now, one of the criteria for any method is that you can provide arguments here that you can supply data to the method. The criteria is, if I was to say, you have to provide the actual type and the variable name. Okay, so if you provide this type and the variable name, you can see immediately my IDE is saying this, it's giving a complaint. And the complaint is that this call to the method doesn't match this call to the method. In other words, the method is now expecting to have a string. Yeah? So in this case, I would have to supply a string. And then it's happy. And you can provide as many arguments or expressions here as you require. So you can put as many as is needed. And we'll go into some more about that in a moment. Another thing is that methods can also return values. So the method that I'm showing you now doesn't return anything. It doesn't give, and we can see that it doesn't return anything by this keyword void. So again, void means it's not providing anything back. Now, if I was to provide a Boolean, there, the word Boolean, you can see now there's an error here. I don't know if you can see that. There's an error here. And what it's saying is that I need to provide a return value. So it's also type specific. So because I've provided the word Boolean, it requires a Boolean. So you have to return a Boolean. So in this case, it's expecting true or false. So this key value here, this word here, Boolean, is the return type. And when you use the keyword return, which is once you specify this element here from void, and you specify a type of any type, whether it be a primitive type or an object type, you then must match that type with the return value. So whatever type that is must be the same as the return value. So if I change this value now to a string, if I try again, if I turn it to a string, you can see now it's giving me an error again saying incompatible types. Boolean cannot be converted to a string. So then if I just provided a string, Bob, you can see now that the method is happy. Okay? So that's a very, very basic creation of a class method. So the key for a class method is that a class method is not created during the instantiation, and I'll explain the word instantiation. But when you create an object or when you run some code, the method isn't actually being created in memory like you would do if you were making an instant method. So if you make an instance, if you create an instance, which we'll cover in the next lecture, of a method, then it creates sort of a mapping for it in memory. In this case, it doesn't. Again, it's just like having a toolbox or something that you can just approach and use at any time, and it will perform tasks based on that. Any questions on that? So, when you're returning an item, so say now I'll return this value Bob, and I've called Thomas. See, I've said, so if I just change this a little bit, if you remember concatenation, I'm now concatenating the text. So what I've done here, excuse me a second, I'll just delete that. I always get a frog in my throat when I'm talking. Okay, so what I've done now is I've added this word text to my output, and what that's done is it's taken the value Thomas that I've passed when I called the method, it's passed it into this section here, which is now being named as text. Again, this can be any word you want, it's the variable name. Text then is a local variable, local to this method only, and then I'm using text here to output the name Thomas. So if I run that, as you can see, this is my car Thomas is now coming up. So the Thomas is being passed during the call to the method. It's being passed into the method and then being used by the method, right? Now, interestingly, because I'm returning a value, I'll change this to awesome. Because I'm returning a value, that means that this statement there actually becomes a string. It actually becomes a physical string. What does that mean? Well, it means that if I was to use it as if it was a string, so now I'll put these brackets a bit wider so you can see what's what. Now I've put it in between as a string, you see. You can see now that I'm calling my car. My car is producing whatever my car does. In this case, it's printing out, this is my car, Thomas, the name that I'm passing. Then it's returning awesome, and then I'm printing out awesome. Does that make sense? So if I run that now, you can see this is my car, Thomas, awesome. Now, if we break that down into the steps that we're looking at, essentially what's happening is, if you remember when I spoke about BODMAS, the brackets are evaluated first. So everything inside this bracket is evaluated, as is everything inside this bracket is evaluated first. So my car is run. So my car is run first. This code is run first. And once it's finished and it does the return then returns back to here and provides whatever value is here for it to then continue using. So this essentially, this entire method becomes the literal of the return, in this case awesome. Now, I'll run that again just to showcase, yes, it's exactly the same. Any questions at this point? Is it making sense? Very clear? I'm really happy to have questions, by the way, honestly. It helps me to feed back to you so that I'm not missing anything. So if you have any questions, if anything's niggling in your mind that's not making sense, I'm always happy to sort of reiterate it or to change the way I'm stating what I'm explaining so that it's clear to you. So do feel free, okay? So far, so good. So again, you can see that this is now producing, I'm just returning a string, right? But that string also can be a subset of the code that you're running. So instead of printing out this, what I might be able to do, for example, is simply return that. Now it's giving me an error. One more thing as well. If you have a return statement, you can have as many return statements as you like within the code, but only one return statement can be executed at any time. And the return statement does two things. One, it halts the method, so that's where it stops. And two, it provides a return value of whatever the type is. And in this case, it's giving me an error because I have two returns. And what the IDE is pointing out is that because this is halting at that line, this code is unreachable. So I can never access that code. So I will just remove that. And in this case, I'm now going to return a subset of, or an addition to this. Now, as you can see, I'm providing Thomas. If I run that, you can see this is my car Thomas coming out. And this is now the return value. Whereas previously, the method was providing a call to system.out.println. Now it's actually just simply returning the value. So far, so good? Okay. And naturally, once the method has been called, control is then returned to the point of calling, right? So if I was to call my car here, Sue, like so, and then maybe call my car here, Bob. You can see, I'm calling the same value 3 times. Can anyone give me shout out quite loudly what's going to be the output for this? That's right. So the output simply will be, this is my car Thomas. And the reason for that is, even though Sue is actually, in fact, returning, this is my car Sue, and my car Bob is returning, this is my car Bob, I'm not actually explicitly asking it to display it. I'm just calling it. And what happens in that condition? That value is just destroyed. It's just lost. Okay? So when you return a value, if you don't do something with that value, then the value is lost. Now I could make a string called Sue, and Sue can call my car, and my car returns, this is my car Sue, and therefore this string Sue will now be stored. It's no longer lost. So if I was to then say system.out Sue, like so. So now this is the variable Sue, which has been created using a call to my car, and that value is provided by the return statement here. Now it will print out, this is my car Sue, when this line is executed. So in this condition, we're creating Sue first, we're then creating Thomas, we're then creating Bob. Bob is being destroyed. And even though we created Sue first, we're printing out immediately. The control from Thomas goes straight back to this section here, which is then printing out, this is my car Thomas. Again, so Bob is destroyed, and then Sue will then be printed out. So in this case, even though Sue is being created first, Sue will be presented last, right? So if I run that code, you can say, this is my car Sue, this is my, Thomas, this is my car Sue. There you go. And again, that's something to be aware of. Just because you're creating something or returning something, it's your job to display or utilize or do something with that return value at the time that suits you. Any questions? No. Okay. So we have a lot of methods, as I mentioned, when I showed you the API. So this here, you've got a ton of methods that are available to you. So here's the math method. And of course, when you call an object, as I mentioned before, from the library, you have to import it first before you use it. So the math object, or the math class, is in the library, and this has a ton of useful mathematical functions that you can utilize, you can use for yourself, and you don't have to create yourself. But this is doing exactly what you can do yourselves, which is creating a class and providing methods, static methods, that you can then use as a tool. So this is one tool that you will be using without a shadow of a doubt through this course. And as you can see, there are a ton of different mathematical equations or various tools that you can utilize, such as round and the square root of. So here's a few that we will expect you to understand. Sorry. So sorry. So the ABS obviously turns any value into an absolute value. So if it's negative, it will always become positive. Ceiling, again, what I'm showing you here is that this is expecting an integer, this is expecting a double. Java does have mechanisms to allow automatic casting in some instances. And again, if you look at the API, you can see whether those are available to you here. So it'll show you where those automatic castings are available. Ceiling simply brings the value up to the nearest integer. So if you give it 1.4, it'll move it up to 2, right? And so on. Hello. I don't know. Can you not hear? Hello? Hello? Oh, sorry. Thank you. Yes, thank you. Hopefully, you'll be able to hear everything on the video, because there are mics here as well. But my little mic here was switched off. Thank you for that. Thank you. So ceiling brings the value up to the nearest individual value. E gives you the scientific notation. Max, you give it 2 values, or sometimes a range of values, but in this case 2 values, and it will give you the maximum. Minimum does the same, gives you the minimum. Floor is the opposite to ceiling in the sense that it will round it down rather than rounding it up. Pi will give you the value of pi. Power, I don't know why they didn't put an ER there, but POW, like Batman and Robin POW, will give you the power of the 2 values, the main value and the A and B here. And the square root gives you the square root. To use these, you would, first of all, you have to import, right? But if you're using an IDE, you can just call math. Oh, if I just do, hang on. So if I was to say system.out, oh, actually, I'll do this instead. I'll do double. Oh my God. Nope. I'm doing a class here. Double num equals math dot. Then you get all these values. I'm just going to say pi, and then, actually I should probably call that pi. Oops. And then you can just system.out pi. I think we may need to concatenate it. This is a quick fix for concatenation. And you can see it gives you pi to a reasonably high value. But as you can, oh, actually, it hasn't called. Why isn't it calling math? Oh, because it's a static. Forgive me. Because it's a static and it's within the Java library, I don't have to instantiate it either. And in this case, you can see that the math class is actually available to call without instantiation, which is thrown me actually. Anyway, it works in the IDE. If it doesn't work for you, it just let me just double check. Oh. Because it's bothered me a little bit, that has. Yeah, so it's from the Java lang object. Oh, okay. So the math. Okay, so the object. We will go into objects in a later lecture, somewhere in the middle to the end of the lectures, where we go into the depth of objects and understanding how the hierarchy of objects work. And the reason math is available is because it's of the type object, which is always available to you. Anyway. So as an example, I've already given a sort of example here, where you've got a main method, then you're asking for some values in from the scanner, and the values that are coming in side 1, side 2 are being provided as parameters here for this math.square root, and the hypotenuse in this case is being calculated using a call. This is a static call to the static method square root, providing the values, and then of course, just as you've seen me do with the oops, don't know what's happened there. Get rid of that for a second. As you've seen me do here with this my car, the actual value is returned in exactly the same way. So what's happening under the hood is exactly what you'd expect. It's actually doing some mathematical equation in a method that's provided for you, right? And the output for that would be, if you were to provide the values, you'd get the hypotenuse as you would expect. Any questions? Nope. So, for every single type primitive, you have a wrapper class. Now, this isn't a beatboxing wrapper, it's got a W. So you would, a wrapper class simply means that because primitive types don't permit you to use methods, Java provides a class for that primitive type to allow you to utilize methods and have more functionality within those types for you to use. And interestingly, you can see that for every primitive, there is a wrapper built in for you, so you can utilize. For whatever reason, int has become integer, long is long, float is float, double is double, boolean is boolean, and char is character. I wasn't there when they were deciding that that was the best way to do it, but that's what they've done. So you will be using these as well. So wrapper classes are very common, and we'll go into more of this when we start looking at overriding and overloading later on. So, for example, if you do provide, whereas if you do provide a primitive type for any of these values, so if you provide, what am I trying to say here? If you have a value that doesn't fit into the primitive type, but you utilize that within the wrapper class, often Java has overloaded, which I will come into in a few minutes, the methods to allow you to do more stuff or to cast that information to the value that you want. I'll explain that more in a moment. So one of the one of the methods that are available in every single class based on the object hierarchy is the toString. So for every, if you want to, for example, turn an int, okay, so you know when I was here, and I do this, this is my car plus text, right? If that was an integer, if that was like the value 1, now Java sort of automatically turns that 1 into the symbol 1 and makes it part of the string, and it returns that value. This is kind of it's used a lot, but it's not explicit. It's very, very sort of it's not the right way to do it, although it works. So I can't tell you not to use it because it works and it's useful. The reason it works is because of the way Java has implemented the string class. But what we have is actually this toString, which does the kind of casting for you. So for every primitive type, you can convert that to a string using the toString, right? Does that make sense? So if you have whatever the primitive type is, if you call it toString through the wrapper class, you gain a string, an actual string, not a converted string or a slightly loose string, but a string, right? And there's reasons for doing that, but this is the sort of key way of converting values from primitive types to actual strings without using the string classes concatenation. I hope that makes sense. It's a good time to take a break. We'll take a quick break, a 5-minute break, and we'll continue thereafter. Thank you, guys. Hey, mate. How are you?
Quick question.
Yeah, please.
I'm not sure if this is your intent, but are you planning to only upload the assignments on the week they're due? Or?
The assignments on the, which, you mean the main assignments, the marking assignments?
The 5-mark ones. I don't know what they're called exactly.
Yeah, so the assessed assignments.
Yeah.
What was the question? Am I planning?
Sorry. Are you only planning to upload them on the week that they're due? Is that?
No. Interestingly enough, they're all ready to go. The timing, I normally give a week. As they get harder, I tend to give 2 weeks. I think there's no reason why I can't give you 2 weeks. I didn't want you to. What I didn't want to happen was for you just to finish the one assignment, the next one to go live, and you not to feel you've had any rest.
Okay.
Do you know what I mean?
Okay, fair enough.
But they are. I mean, they're
not very long or anything.
No. If you know what you're doing, and some of you guys do, I understand that they're trivial. But for those that are learning fresh, it's harder. You know, it's a challenge.
No.
I've got the next one. I don't know if it's gone live or not. I can't remember.
I'm not sure. I checked yesterday.
Okay. Yeah. So the assessed ones, yes, it's normally a week depending on how difficult they are. And remember, there's one main assignment as well, which you get a longer time, and that is a challenge. It's expected to be a challenge. It's supposed to be, so that might be more interesting when the time comes.
Totally curious.
Yeah. No worries. Thank you. Yeah, no worries. Hello. Sorry. Yes. What do you need to know?
My lab tutor doesn't specifically using Mac and also the networks. So when I was trying to run the class, I was like, and I didn't press run.
Oh yeah, that's okay. Yeah. Oh yeah. Well, you using a PC or a Mac?
A Mac.
Okay. So what I do to run is I just hold Shift and Function and press F6.
Oh yeah, that's exactly.
Yeah. So the reason I do that is because sometimes I'll have more than one main method in a package. If you have one main method, all you do is you go to here, you right click, you set, this would say unset, but you set as main project. It will look through it quickly, find the one main method and say, do you want to use this main method? You say yes, and then all you have to do is to click play. But because I have several main methods, I tend to just run the specific class, and that way it sort of makes it easier for me. But yeah, any questions like that, just throw them at me and I'm happy to answer them as needed. So yeah. So just again, it's okay to do that. It's absolutely fine.
Because my computer also, it often takes a couple seconds or 10-20 seconds to run a specific task.
Oh really?
Yeah,
Oh.
Wondering if I was doing it right.
I don't know. I mean, if I run this, it's immediate.
Yeah.
There's no delay. It does have. Go and check online and look at the builds of not Eclipse, NetBeans. Sometimes I know, for example, and I'll show you some of this stuff later. But when we start doing code generation, mine locks up. The minute I use automatic code generation, it locks up, and I have to wait a minute, 2 minutes before it gives me control again. So check that maybe the build you've got has some of these issues. It could be just NetBeans being a pain in the butt. So I don't know if that's any consolation, but it shouldn't. Normally for code, it should be like this, very quick. So I'm not sure. Yeah. Okay. Awesome. Yes. Hello.
So in the discussion board, I just noticed like we are not allowed to share any polls. We can't discuss about any-
Certainly nothing for the assessment. Yeah,
Okay.
yeah.
I have this interesting problem from the book, Absolute Java, that I really thought we could discuss on the discussion board. But since it had that thing written, like we can't share any code, I sort of like took back a step and did not.
Okay. I see your point.
Yeah.
I think you can look. There's nothing wrong with you taking a photo of the book and saying and discussing what you're seeing, and that way you can't be accused of using your code and sharing.
Yeah.
Because it's in the book.
Actually, I wrote a code as a solution to that problem, and I was thinking whether I could get some help for writing a more efficient code. But it's not assessment related.
Okay. Generally that's what the workshop should be for, and you should be able to ask that. I've lost it. You should be able to ask those questions at the workshops. If they're very specific and there's no resolve at the workshops, have a chat with Nye. And the reason I'm allocating work is just because my workload is so heavy that I'm happy to help. Don't get me wrong, and I'll help wherever I can. But generally, you use the sort of steps first to see if you get a solution. If you can't, then just fire me an email. One thing to note: code doesn't get sent through email. It gets banished through the servers. They won't allow code to be sent, so you'll have to sort of discuss that in a different sort of way rather than sending me piles of code, because it just gets ignored basically, or removed. So you know what I mean. So I don't know if I answered your question or not, but
I was thinking whether we can have a separate thread on the discussion boards.
for sure.
Just for codes, if people want to talk about codes.
Yes, no, absolutely. I appreciate what you're saying. The difficulty when you start talking the code is that some students may end up putting code that is part of the assessment on there. And because we have such a range of students, we've got some that are really starting out and others who are advanced, and they just want the rubber stamp. They just want to be, they just want to have that certificate. And for those, the high-level ones, they could easily go, "Oh, this is easy. There's the solution," and then that's where we have an issue. And so it's always better to sort of try and avoid that on that. Really, I know it's unhelpful, but it gives us headaches on a different level behind the scenes when code is shared, and it will flag up as well as a similarity on the similarity checking. Yeah. Sorry, I couldn't be more helpful, but yeah. No worries. Thank you. Sorry, did you?
If you have time for one more question.
Quickly, because we're about to start.
Yeah. Okay. So how do you pass in a pair of arguments when using the string?
You want two arguments?
Yeah.
Okay, I'll show that now.
Okay.
It's a good question.
Do you do just like a sentence or a phrase that in a pair of quotes, and then you do like arg bracket 0 or arg bracket?
I'm not sure. Are you talking about the command line, or are you talking about the code?
Say this, if I want to pass a pair of arguments in to my car from the
I'll do that now for you. I'll give you an example. That's a good question. Okay. Hello. No, that's not working. Hello. Hey. Okay, guys, we're back. I had an interesting question which I hadn't covered, and I think it's definitely worth reviewing. The question was about multiple arguments when using a method, and this is so important because you will need to pass multiple parameters to your methods at all times. So the simple way, which I again thank you for asking, is that you simply put a comma and then you put in the next argument, so whatever that would be. You keep doing this until you've given the arguments that you want. So now I've got, in this example, my car, I've got text2, and I've got int a. And exactly the same thing. As you can see now, my code's complaining up here because it's expecting me to give the same amount of values for each one of these calls. So in this case, you can see that you have to essentially marry I almost said marry there. I suppose I can. You have to marry the same number of arguments and the same type of arguments with the actual input parameters that you're looking at. So whatever you want to provide to the method, when you call that method, you have to supply the exact same number of values, including the order of the types of values. Okay, so you can't mix those values up and it will find them. But that brings us, interestingly, to a concept known as overloading. Overloading allows you to create another method called the same thing. So I'll do that now, even though it comes in the slide later, but as soon as I'm here, I'll cover that now. So I can do public static, and I'll do the same thing, string my car. So you can see now this is exactly the same thing. Java's happy for me to do this, so you can have as many my cars as you like. But the signature, okay, so Java looks at the name of the method to decide which method to run, just like it does in many other languages, so C, etc., etc. But it also looks at the order and the number of the passed parameters, right? So this is called the signature. So this my car has 0 values. This my car has 3. You can make as many. The error there is just because of the return. So if I just say return Bob, just as a string, that's happy. I can make as many methods with the only differences being the number and order of the passed parameters as the differences. So the cool thing, and this is really useful, hang on. The really cool thing about Java is that it allows this, which means that when you're creating static tools, if you're creating tools and you have a bunch of floats that you want to deal with, and then you have a bunch of doubles that you want to deal with, and you have a bunch of ints you want to deal with, and then you think, oh, what if they type in strings? I can cast those, so then you want a bunch of strings to deal with. You can create the same method with the same name, which will allow you to take in any permutation that you can imagine of parameters, right? So in this case, when I'm running, say, this my car or whatever, or say this Sue one, if I was to say with Bob, so if I say string Bob equals this, now my car, it will no longer run this my car. Instead, because there's only one string there, it will look at that signature, it will find if there is a method with the same signature, and in this case there is, and it will run this signature, right? Sorry, this method. And again, if I was to say system.out like so, I'm simply using this call. You can see there's nothing provided here, so it will check, is there something there? Yes, there is. It won't be that one. Here, it won't be that one. And in this case, it will be this one. So in this case, it will run that method, right? Make sense? Right, so that's a very good question. Thank you. The slides will catch up with me, just because that was asked. The slides will catch up with me later, but we'll just gloss over that. Okay, so as well as having the toString, and we'll be programming our own toStrings in future lectures, we also have the parse value. So you've already probably used integer parse int when you take integers from the command line or from the scanner to convert that string symbol into an actual integer or a float or whatever value. So these for each single data type, primitive data type, you have a corresponding class which has a parse byte. The only one that you can see there that isn't is, sorry, I am sorry about that, is the char, because you don't need, if you have a string, you don't really need to parse the string. You simply need to take one value. So the only one that isn't available is the actual parse character, which you would imagine would be there. Instead, you simply take S would be the string that you have, and you would simply use the char at and give it an index value for that character, and then it would turn that into a single quoted character of the char domain. Make sense? Right. So, so we know about the main method. It begins I'm not sure why this is here actually. So we've covered the main method. We've covered the arguments of the main method. We've now covered the static portion of the main method, in that the static keyword indicates that you can call a static method without making an object or a memory allocation of that. And of course, as you already know, it begins like this. This probably should be something for the first lecture, really. I'll look into changing that. So this is just covering what we've covered. So the variables are called parameters, which I've been using. When you create, again, when you create your methods, just like the main method, for now, when we use the static keyword simply because we're using our methods from a static context. So because we're calling from the main method, and because we're not creating an object yet, so we're in a static context, what we end up doing is that we have to utilize static methods. And I don't know if you guys have tried to play around or fool around with methods and have had the error where it says cannot use that method outside of a static context. That's one of the errors that you will get. So the body part obviously is between the curly brackets, so as I've gone through with you. So this is, again, just highlighting that when you create a method, you use I'll look at the basic one here. You simply, if you're inside a static context or you want that method to be utilized like a tool that you can just use at any time, use the static keyword. Then you provide a value that indicates whether you will or will not be supplying a return value. In this case, I'm saying we're returning the string object. Of course, if we didn't want that to be, we would then have to put in the word void. So if you don't want it to return anything, that's okay. You simply put in the word void there, and in that case, it doesn't require to have the return value. Okay, so that's one of the conditions. The main method also doesn't return anything unless you call system.exit, which is what I mentioned last week, I think. System.exit exits out of the program. So if I put in a system.exit here and put in the value either 0 or 1, it will return that 0 or 1 as part of a sort of a hidden return, but it isn't a return. It's really just this system class that's providing that return, not the actual main. So if I run that now, it'll simply call the first. It'll just run the first line and does nothing because it doesn't provide a return, any other sort of outputs of any sort. Okay. Any questions on that? In the system.exit. So the question is why you put a 0. Well, it kind of harkens to C programming. A lot of some, should I say, of Java's infrastructure is kind of borrowed from C. And when you have a 0, 0 and 1 represents true or false. That's simply a way of, you can put a 1 there as well. You can put any other value, I believe. Actually, let's try that. I don't know if you can put other values thinking about it. Yeah, there you go. So Java result 12. So it is exiting. So if you give another value, it's simply, yes, you can put any value in there, but that's really for you as a developer. If you're exiting, it's kind of almost like an ejection. You would never use system.out to finish a program naturally. Sorry, system.exit. Generally, you'd exit in a more natural way by sort of just ceasing or coming to the end of, or exiting a loop generally. So system.exit is very much a forceful exit. And as a developer, you may want to have error codes that you provide to yourself when such an event happens. We'll get into that when we look at error handling. We'll discuss that in more detail in later lectures, but a very good question though. Yeah. Sorry? No, I think you do have to give a value. There you go, yeah, so it's expecting a value because it's essentially exit is a method, and in this case it expects an integer. So in that context it wants an integer, much the same way as I was explaining with the rest of the code. For, you know, if you create a method with a certain amount of parameters, then you must supply those parameters. And in this case, the system.exit hasn't got an overloading of 0 parameters. So yeah. Thank you. Any other questions? No. So as I've gone already through, so you return the results. This is just catching up with what I was already explaining. So when you return a result, you have a return expression. If you're in a situation where you have this void, I think you can still use the return value, although it's return value, but providing no parameters, so you don't actually return anything, just for it to exit that function at your will. So if you've got like lots of things going on within loops and stuff, and you just want to get out of that function at a given point without using break or without using any sort of clever tricks, you can actually call the return value without any values, even though it's not, see, it's expecting nothing, so it's providing nothing. So those two still match. So the return value is still valid in terms of its function, but you're providing nothing, void, nothing, empty. And in that case, you can still use return in a void context, which, to be honest, it's not very often you would do that. I don't often use that in my coding, to be fair, but it is available. You can have multiple returns, so you can return in the context of having, say, if you were to have if s dot length is greater than, say, 5, so that's giving some context. Do something, you can return return some other string, because it's a string, right? So you can see that there's one method, and you can now see that there's 2 returns. You can have an unlimited amount of returns, but the criteria of that is that the return must be accessible. So you can't have a return that blocks another return. In this case, it is the if statement that's providing a change in direction of the code, and if that is true, it will then return at this point. And as I mentioned, the return value does 2 things. It returns a value, naturally, but it also stops the method from running. So in this case, this would terminate at this point, right? So it would return that. And then, of course, you can have another return, and this will give an error now, because I'll show you why. So you can have a return. It should give an error, because the else is simply saying if that doesn't happen, then this sure as hell will, right? So if something is going to happen, otherwise it's not. And this return is now blocking that, even though it's inside these curly braces. Do you see what I mean? But if that was an else if, s dot contains something like so, then that would be happy with that. because it's now saying if this condition is met, return this. If else, otherwise, if this condition is met, run this, and otherwise don't, just run this, right? But if I put an else there and returned, oh my gosh, return some other value, again, we have the same situation. So that's something to be aware of. And now, even if, let's say, for example, this was an integer, okay, and let's say that this was also an integer, and let's just say that if you were saying, look, if s is less than or equal to, or greater than or equal to 5, or else if s was so less than 5. Is that right? Else if incompatible string. Why is it having that error? Illegal start of expression. Else if that. There you are. So these are just asking for numbers now. So even in such a situation, you know, we all know, I'll get rid of these, in such a situation, you know that that's going to be met, right? So you know that if it's either greater, either s is greater than 5 or equal to 5, or it's less than 5, and we know that's going to, one of those is going to be chosen. But Java's a little bit stupid in the sense that it doesn't trust the code. In this case, because there's no else, it's moaning that it needs a return statement, because it doesn't believe that this condition can always be met for whatever reason. Now, logically, as humans, we can work that out pretty quick, but as a compiler, it can't, so you would have to just have some value and return that as an else. Or, if you didn't have that, you could just return some other value outside, as long as there's a return that it can reach. So there's another thing with the returns. You can have as many as you like, as long as they all can be reached, and it must find a return somewhere in your code, no matter what the condition. Okay? So far so good? And of course, there's a compiler error if they're violated, as you could see. Here's another example, just going through a different. I'll just gloss over this because again I'm catching up with myself now. Gives the outputs, much that we've done. So a quick poll. So if you get your electronic devices out, and if you remember, it was. So I think we can go to bit.ly/t Christie, like that. So if you go to that, so bit.ly T Christie, and it'll bring you to the poll. And the question, let me get this into some kind of order. Nope. Right. Oh. So the question, get rid of that as well. So the question is, what will running test integer 4 return? So if the main method wrote test integer 4, what will be the return? I have a minute. I can see you all thinking. Everyone casting your vote? Have a guess if you can't work it out. Now, obviously, as you're working it out, this kind of question is the kind of question that does come up in an exam as a very low mark, just because it's designed to make you work through some basic code and understand what's happening with the integer values. Okay, make your selection. Ready? Everyone ready? Shout no if you're not ready. Okay, I'll count that as a yes. Oh dear. Not sure why that's not working. Ah. There you go. So the majority are saying B, which is 1, quite a few saying C, and then it's pittering out with D and A. Now, for those of you who did get it right, it was 1. Yeah, so I won't go through it with you. You can run through it with a piece of paper, writing down the values, but the answer is 1. And you've got to remember that the key here is that you're returning I, but on... Oh, sorry, which one that runs is whether it's returning I or whether it's running J. In this case, it's returning J, but when the condition of I is met. So that's kind of a little play on the variables, and that happens a lot. And in fact, you get that a lot in coding anyway. Okay. So when do we define methods? When is the right time to define them? I would argue you always use methods. You barely ever... in fact, every time... I can honestly say every time I code on a professional context, so I've coded for huge companies, you always use methods. You always launch into a method immediately. You barely ever write code inside the main as your main sort of instigator for your solution, right? But generally you want to sort of never go over 60 lines. If you've got code that's going over 60 lines, you want to consider putting that code into a method. 30 lines is even better. If you have a situation where you have code that's been utilized, the same. So if you've got the same kind of code and you're using it again and again and again, then put it in a method and call the method. It's really easy, really useful, really functional. And also, if you've got a sort of a type of code that you can give a name for. So if you look at the Java math class, the square root of is a very useful function and with a useful name. And again, in past, and if you've been in any of my other classes, you'll know that I often use a debug method. So what I will tend to do, I will always make a private static void method, and I'll call it debug. And the reason I do this is that I simply want to be able to output some value to the console on a certain condition, and that condition usually is if, and I'll do if debug like this. And what I will do, for me, debugging is one of the most time-consuming tasks you do, and you do it a lot. Nobody writes code perfectly the first time. You'll always find errors, even if it's a semantic error, and we'll go into all that, whether it's just an error that you're not getting the results you want, but there's no errors. So debugging is a... So, what's wrong with this? Oh, Boolean. So, I always do this in every piece of code that I do. Not that you have to do the same. I'm simply highlighting it as a point that I have a task that I use all the way through my code. And when I run this, so when if I want to know what's going on in my code, I simply say debug, and I give it a value. I want to say something at Sue, right? Oops. So at the moment when I run this, oh, what else is going wrong? Let me just get rid of any errors just like that. So now you can say I'm at Sue, but when I change this to false and run it again, the same code, it doesn't show the debugging. So I can switch debugging on and off, and put all these debug things all over the code. And they are. If you look at my code, I'll always have these debug statements. And of course, the compiler, the Java compiler, I'm going to say in theory, but it should do it. It looks through your code and it gets rid of any, when it's creating the bit code, it gets rid of any code that doesn't do anything. So the debugging, in terms of your efficiency, once it's false and it's never activated, is actually dismissed from the functionality of your code, so it doesn't affect it. Anyway, the reason I was mentioning that was simply to highlight the concept that if you can give a good name for a chunk of code, then use a method for that as well. Naturally, working out what elements to put in which method it's a big task that everyone faces every day. It's a lot of work that goes into it. But the bottom line is just think, look, anything nearing 60 lines of code, consider putting it in a method. Try and aim for 30 as a general rule. I've already mentioned this, so I'll just skip over that. I was going to give a method example, which I've already done, so we'll skip over that. I've discussed headers and signatures. The header, so up until the curly bracket is called the header, so the actual name of your function is called the header. The signature, as I mentioned already, is the part of the code that has the parameters, and Java uses those to decide which method to run. And that's an important thing. As we'll go into that, and the keyword, I don't know if it's written there, but the keyword for that is overloading. So you will need to know what that word means, overloading, and not to be confused with overriding. So those two features we will go into, we'll be using a lot of during the course of this lecture. So that wraps up that element. So overloading being a key factor. Now overloading, when you use the maths ABS or min or max, it doesn't specify whether you should have a double, a float or an int. It takes the value that you give it and it just knows what to do with it, and that's part of the signature. So it's not casting really, it's not really changing the value that you give it. It's using overloading. So overloading simply means that you have more than one method of the same name, and that method has different parameter values and order. Now, obviously, there are some limitations, which I'll go into in a minute, but you will be expected to design your own overloaded methods so that you can ensure that your code is running efficiently and catching a variable or variety of user inputs, and that's just something that you'll be expected to do. The limitations. Now, the issue that you have is that Java does, as I mentioned before, sometimes it does auto casting. So when you're using an integer or a double, if you give an int and you do a double calculation or something, it'll, depending on the order, it'll cast one or the other into a double or an int, right? And we've all experienced that in losing accuracy with our code. So you'll ask it to do a 3 divided by 2, and it just gives you a 1 instead of a 1.2, or similar, vice versa. You get the opposite in other ways. But when you're overloading, one of the limitations here, as this example, is that if you have a method called the same, so in this case you have a method called bad, and on one side it has int, and the other side it has double, and then it has double, and then it has int. And let's just suppose that these methods are doing a different thing, right? Now, Java will accept that. They are different, so it will accept that. But in terms of the output, you won't really know which method is being executed. And if the functionality of the method is very different, you may get wonky results. So you want to avoid this kind of thing. at all times. It's not something that, it's a semantic issue where you'll get the wrong results even though you think you're doing the right thing. So try and keep that kind of thing away from the automatic conversion, which I often think that having automatic anything sometimes it leads you to disaster, because it's trying to assume things when you're trying to be very specific. And another thing to be aware of is that you can't, it doesn't take into account the return value. So if you have a return value and you have the same name, same function, same parameters, and only change the return value, that doesn't work. The signature is the parameters, and that's the key that it looks at. So the return value has no bearing on which method it selects. Public or private. So there are 4 types: public, private, protected, and I've forgotten the other one, but we'll come to that later. But for now, public and private indicates whether a method is visible and usable by other classes. So what I'm going to do as a way of showcasing this is I'm going to make an additional, so I'm going to right-click on here, click on, and we're going to make another class. And this class, we're going to call it example2. And in here, I'm going to make a method called mycar. Sorry, I'm going to say public mycar. I'm just going to do it very basic. Oh, sprout. Okay, I'm just going to call it mycar. Example 2, public static void. Okay, so now I've created a class called example2. I've made a static method called mycar. And what I'm going to do is I'm going to go back to here, so the main method. I'm just going to comment all this out. I don't know if I've explained that before, but if you put a slash and a star, everything after that will be commented until it sees a star and a slash. Right, so all I did is put a star and a slash to comment everything out. Now, if I go to example dot, example2 dot, you can see that the mycar is actually available to me. So if I run this code now, it is actually calling mycar example2. So if you remember the code, excuse me, here is simply saying mycar example2. So I'm calling, in example 1, I'm calling example2, and I'm accessing the class mycar example. So let me just do, I'm going to call it mycar2. And this again is public static void mycar2. What am I trying to do here? Let's try to save it. I'll go back to example 1. And then if I do example 2 and dot, you can see mycar2, right? So if I say mycar2, save that, go back to example 1, and I run this, as you would expect, you've got mycar example 2, mycar2 example 2. So far so good. And if I change this to private and save that, suddenly this is giving an error. So when I now click dot to see what's there, I can only see mycar1. So immediately I've hidden that method from any of the classes from utilizing it. Does that make sense? So in essence, even though this is a function that's totally there, it's totally functional, this method is inaccessible to classes outside of this class. Okay? So if I was then to here call mycar2, it's happy. It's okay to do that. So if I save that now and get rid of this and run that, again, now we've got access to that class, but through the other class. Did you see what happened there? Yeah? So this is private, but it's only private to classes that aren't it. So it's not private to itself. I was going to say a crude joke, not a joke, but like when you're in the shower, everything about you isn't private. You're not private to yourself, but you're in the shower and you're private to everyone else, right? And that's the way it should be in most cases, right? And it's the same sort of thing here. This is car2 is private, and therefore it's not private to itself. This is the class that owns that method. Therefore, this class can access that method. But this class here doesn't own that method, and it's private. Therefore, this class cannot access that method. Any questions? No? Hopefully that's reasonably clear. And what that does is it highlights the visibility of each method, so you can control the visibility of the methods yourselves. Now, one rule of thumb would be that if you can make it private, always make it private. So every time you're coding, always just say private, 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 private. And only when you want to give access to other classes for whatever purpose, and you will need to do that, it's only then you should make it public. So the rule of thumb, everything is private unless it's public. It didn't really roll off so well, but everything is private unless you need it to be public. And that's the best practice. Just make sure you do that all the time. And that's the same with signatures as well. So if you change the signature, but you make one public and one private, it's always the same thing would be the case. So if I was to make this code with a different signature, like this, and make it public, and then run that. So my car example 2, or if I said my car example 3, if I put 3 there and run it, what I'm seeing is my car example 2, because if I click in front of that and press Control and space, you can see my car 2 is there, but only the one with the signature that I made public. So you can mix and match as well. So just because one method is private, the other methods can be public. Again, it's entirely up to you to enforce or be the doorkeeper and control those. But again, the rule of thumb is make everything private unless you need to access it externally. And otherwise, you'll open a huge can of worms. Public methods can be accessed from anywhere. So even another application can access them. So just be aware of that. Another thing is there's something called the scope of the variables. So in a method, when you create a method, for example, in fact, I'll stick with this myCar method. So if I go here, so the myCar is the myCar1. We're running this one. If I create a variable, int a equals 10 here, that variable is only accessible inside that method. In fact, Java has this quirky little condition that if you put a variable inside curly braces, it's scoped or local to those curly braces. What do I mean by that? What I mean by that is, let's say I say int a equals 10, and I say just print a, right? You know it's going to just print 10, right? So this is the 10 we're looking at. But if I was to say int b equals 20, and I was to say print b, let me just show this in proper context, you know what it's going to do. It's going to print 20, right? But if I was then to say print b here, it can't find it. Can you see it's got an error? So if I try running that, it's saying it can't find runtime error. It can't find, essentially it's saying it can't find b. Even though b's there, b's not inside a method, b's just been scoped inside those brackets. So be quite careful of that, even though it's not a method. But with that, going back onto what I'm mentioning, I'll get rid of the error. The point I'm actually making is when you're looking at methods, the variables that you declare inside a method, even inside the same class, are only available in that method. I often use the analogy of a street and a house. Anything that's local means local to your home. And a method is like your home. Everything that happens inside that home stays inside that home, unless you put it outside where everyone can see what's happening. And that's much the same way. So if you wanted to use a method, say for example I had a method called Bob, like this. If I utilize Bob here, and what's it complaining about now? Non-static. Okay, let me just put it in static. We'll come to non-static next week. Now you can see I can use Bob there, and much the same way I can use Bob here, right? So I've got two methods, both using Bob, because Bob is global. Bob is in the street. But A is local. So A can only be used inside this method where it's being called. If I try and call A, obviously, inside any other method where it's not being used, I don't know if you can see that, but it's got an error there. It basically can't find it. Pretty simple, right? Straightforward, hopefully. I'm just keeping a check on the time. So just to recap, variables are they're limited to the brackets. Once you've run through the brackets, the variable disappears. It's not persistent. It's scoped within. So a method variable is kept within a method. Even in anytime you see brackets, and I think that's the key. Anytime there's curly brackets, if you put a method, or if you make an instance of that, when you define that method, define that variable using its type, that is then scoped to that brackets, and that's something to be aware of. And obviously local variables, because they're local to the method, so when you have a method, if you have a variable here, it is automatically private. Unless you can access that method, for example, if I put one here, int a equals 20, unless you put the variable, unless you can access mycar2, then you certainly can't access the variable. So they're automatically public or private based on whether they are in a method that's public or private. And a key as well, all local variables can be named again in other methods. So if you have a variable inside a method, you can use the same name inside another method, because they don't exist outside of the method. So you can have the same name again and again and again if that's what's appropriate for what you're doing. It's not always a good thing, though, depending on the use case. Constants. When we define constants, what do we mean by constants? Now, when you have a variable, like here you have int a, and I put this Bob here, didn't I? And he's Bob, he's 100. Now, if I choose a variable, if I do static int, and I just say Sue as another variable, and Sue is equal to 500, now, that's also a variable. What does it mean by variable? It means that the contents or the literals inside that variable can change. So I can change 100 to be anything I want. In fact, I could say that Bob equals 23. And that's okay. We can do that. That's called a variable because its contents are variable. You can change them, right? However, if you type in the word final in front of it, this makes it a constant. That means that it can't be changed. And that's important. Let me just, sorry, something's bothering me here. Oh my God. Also get used to privatizing your variables as well. That's very common. That's something you should do. Sorry, it's just catching my attention. So now I've changed Sue to private, to final. It means that Sue cannot be changed. But by doing so, I have a responsibility to the wider community to change Sue to be capitals, right? Oh my gosh. So Let me zoom in on that so you can see what I mean. So at the moment, it's all variables are lowercase or camel case. So if there's two words, we put a capital letter on the second word and every word therein. But when you're using the keyword final here, which means that this value is going to be fixed, we actually are encouraged by the community, by the norms of programming, to use uppercase. And if you have different words like Sue, Smith, then of course you put an underscore to separate the words. And this is the norm, this is expectation in Java programming. Now, of course, if I then try to change Sue Smith equals 34, it won't allow it. You cannot assign a variable, you cannot assign a value to a constant. We use constants all the time. We have this concept known as magic numbers. I've only got a short time. We have magic numbers, and what magic numbers are is the concept of, I can show you here. Yeah, so if I have this value here, a magic number is that if I said x equals 168, you'd be like, well, when you're reading through this code, remember we code for other people to read, also for functionality, but when you're coding, always have it that someone else is going to read your code. So if I was to do this 168 is a magic number. It's magic, it just doesn't, we don't know what it means, but whoever wrote it does, right? And that's what we mean by magic number. And what should it be? In this case, if it was x equals days per week or hours per day, as you can see the uppercase, these are fixed values, and that makes more sense. I personally wouldn't use x as the variable name, but as a way of giving you that understanding, never have, so in other words, in your code, never have magic numbers. Don't sprinkle mysterious numbers everywhere. The only times when they're useful, and you can use them, is when you're saying I equals 0. That's okay, because that's the beginning. But even then, you go to the length of something. Often we say I equals 0 to 10, or some other value. That can be accepted in the context of a loop. But generally, anytime you want to give an arbitrary value to an integer or any other value, it's better to use, if it's a fixed value that doesn't change, give it a name and do it as a final or a constant. That make sense? Any questions? So now this is just explaining that, for example, 6 is an arbitrary value, but back before this year, anyway, when this slides were written, 6 was the actual numbers of the number of symbols within the code. I think we have 9 now, so it's comp 90041, which is 9. But back then it was 6. And the reason why it would be important to have chars in subject code that you write it once at the top of your code, and then when there are changes and you've utilized 6 everywhere in your code all peppered around, you can then just say, well, I've done it once, I've used this constant value. You can just change the constant value once. So in essence, at the top of your code, where the class is beginning, you put all your constants there, you give them the appropriate names that you want them to be, and if the need comes to change a constant that you've used all the way through your code, you can change that one value. That makes a huge difference, I can't tell you how many times using constants has saved me days of work, to be honest. So when not to define constants, you don't define them like this, like 7 equals 7. Everyone knows 7 equals 7, and it would be, not that Java would complain, it wouldn't, but the next person who reads your code might have something to say, right? They might be like, come on, you're being ridiculous. And again, if you're defining a 0 as the beginning of something, there's no need to define that as a 0. We will go into, when we start going into different constructs and different structures later on in the lectures, we will discuss how we define these further, but for now, the key is don't use magic numbers. And a magic number is basically a number that you've invented for the purpose of solving the problem that you're dealing with, but you haven't given it or assigned it a variable name. So don't use magic numbers anywhere, because you'll end up losing marks. So when you do your assignment, you have the big assignment, we will be looking for this kind of thing. So you'll lose marks, easy marks, that you would easily have kept because you might have magic numbers in your code. So variable naming is an important facet for general code design. So I've mentioned class variables already. Class variables are what I called the global variables. So this is just harking back to having a variable outside of a method. So you've got a variable outside of a method. It's static. That becomes a class variable. It lives for the lifetime of the class, unlike a local variable that lives for the lifetime of the method call. Right. So a local variable dies the second the method call is returned. Whether it's returned with a value or without a value. And even if that value is returned as the value that's returned, the local variable is dead. The value is passed on, so that you're keeping the information, but the actual variable is, you can no longer call it. Again, only one copy of each class variable at a time, and where you can declare things private, always do. Keep away from using public unless you know that that's what you want it to be. Sort of, if you want to put your stuff in the public domain, if you want, for want of a better term. So, looking at the time, here's an example which I'll let you look through in your own time. And again, it's just showing the example of the outputs, showing how an example of method use. I've given you, I think when this is normally run, there's less sort of physical demonstrations, which I'm obviously going to try and keep doing. And here's a quick summary, just highlighting the static. We will go into non-static methods, and you will use non-static methods more. Static methods are less. Well, you use them a lot, but I think non-static methods is what you generally use, because once we start going into object designs and creating objects and going through the concept of object-oriented programming, to make an object, you do what's called an instance of a class, and by doing an instance, you're creating an object, and therefore not it's not a class. It's no longer a class method; it's an object method. Method calls can pass arguments, multiple arguments or non-arguments, your call. The arguments act as a signature, so the order of those and the number of those are important. In overloading, that's what it's called, not to be confused with overriding, because we will be overriding methods as well. And again, go with private instead of public, only unless you need to. And multiple methods can have the same name and should have the same name when they're doing roughly the same things but with different parameters. Any questions before we close? No? Okay, thank you guys. Now remember, Professor Peter Shaktay is here next week. He's an excellent lecturer if you've not already had him. So it should be a real joy to have him teach you. And I will see you in 2 weeks. Thank you, guys. That's okay. Let me just stop this a second.